offices in Barcelona, Amsterdam, Austin, Yerevan, and São Paulo, so across the world. And regarding the technical stack, our backend right now is powered by the PHP 8 with the Postgres. It's a monolith, and front-end as well, it's monolith, and we are using pretty classical stack with TypeScript, React, Redux, and Redux Toolkit. So that's all for the introduction. Let's get to the point. So why do we need to change our code? Besides the feature implementation, yeah? So one of the reasons, and one of the obvious reasons, is because of evolving business requirements. So what could be started like a simple startup with an application with a couple of screens in a few years can become a mighty application with dozens of screen use cases and features. And to keep up with the pace of business growth and to keep up with those changes, we need to evolve our code base to get it ready for this new requirements. Next, the tools, the approaches, the industry standards are changing. And I have a question. How many of you are front-enders? Okay, okay. In my topic, there will be not a lot of examples, but the examples will be regarding front-end, but I guess they can be as well applied to the other in backend, etc. So, for example, here we have a simple React component that is written in the approach that we used to write 10 years ago. And for comparison, the same component, but it's written in a modern approach. And in comparison view, you can see that the only part that kept unchanged is the JSX code. Everything else is completely different approach to write React components. Yeah, it's the same tool, the same framework, but we used to write code different. So the same situation with the frameworks, with the libraries, with the approaches, etc., etc. And we need to keep up with those changes to prevent growth of legacy in our code base. Yeah. And the last reason, for the last, I guess, 10 years, the web application become much complex than they used to be. So for example, right now we can have a full-featured video editor in our browser. So it's like amazing. So summarizing, we need to update our code base to adapt for the new business requirements and industry standards, and to improve its maintainability and scalability. And to help us with this, we have 3 wonderful approaches: refactoring, rewriting, and re-engineering. So let's start with the refactoring. And you know, one question: who have maybe negative experience with the refactoring story? Yeah, nice. So yeah, a lot of people have concerns and fears about the refactoring. And some people think that fear that it can take too long, or the developer can break something. And indeed, these fears and concerns are actually non-groundless, because the developers can tell refactoring, can say refactoring, and mean absolutely different things. For example, small rewrites, code changes, architectural changes, large rewrites, re-engineering, etc., and anything in between. So the misunderstanding in the true scope of refactoring can lead to a lot of negative things in your work that you actually won't want to face with. And there is a book that can help us. It's called Refactoring, Improving the Design of Existing Code, that is written by Martin Fowler. And it's a monumental work that can help us to understand what is the true scope of refactoring. So in short, we should not change the module behavior or external interface of some module during the refactoring. The true purpose of refactoring is to make our code easier to understand and cheaper to modify. So, because the well-organized code reduced complexity. Let's take a look at the example of refactoring story. It's a real-life based story, which happened personally to me and my colleagues a few times. Of course, the example is imaginary, but the pattern of the story is always the same. So imagine we have a task. We need to refactor on some widely used component.js. And our motivation to refactor is to prepare our code to implement upcoming feature easier. So what do we have? We have a legacy JS class component, and it's widely used. It's more than 100 usages in our code base. And our initial scope of refactoring is to cover component with tests, rewrite to functional component using TypeScript, and get rid of legacy prop types and default props. When we are starting our work with this component, we can find some problems. For example, completely lack of test. We can find some bug in the component logic. And we can find that the interface of this component is completely unoptimized. It's completely unoptimal. It have a lot of unused props. It have a lot of props that are not used, etc. So while we are working with this component, we're thinking, hey, I'm already touching this component. Why not to make it normal? And we're starting our work. So the actual scope becomes the next. We covered component with tests, rewrite into functional component using TypeScript, fixed bugs in logic, updated component interface, get rid of legacy prop types and default props, and updated all the usages in our code base. Let's take a look on the timeline. So we were expected that we are performing refactoring, then we are doing rollout, and then we can start our feature implementation. But with the actual scope, actually, our life cycle becomes the next. So refactoring, the phase of refactoring already took twice as long as we expected, because we changed the internal behavior of this module, and because we changed the interface of this module, we need to change all the places that this module used. So we automatically need to retest all those places where this component is used. And it can be quite a lot of work, especially if it's used across all the project. As you can see, in comparison with the expected lifecycle, the actual lifecycle much more larger. And let's imagine even worst case. So imagine we have other team that developing some feature. And unfortunately, in their work, they are using our widely used component. So in this case, we have a huge problem, because right now we cannot just roll out this feature. We need to wait until they merge their feature. We need to resolve conflict, and only that we can perform the testing, rollout, feature implementation. And in the comparison, you can see that our actual life cycle of this simple on the first side task become more than twice as long as we expected. So actually, it's not quite rare situation. It happened to me, it happened to my colleagues a few times. And let's talk about the insights. What can we draw from this story? First of all, because we misunderstanding of refactoring can lead to a scope creep. So what seems like a simple refactoring task can easily expand into much larger project, causing delays and frustrations. So this often due to misunderstanding of the true scope of refactoring, because in our task we actually made a lot of things that are actually not in the scope of refactoring. And it's crucial to set clear boundaries for refactoring tasks and limit our work. Next, separation of concerns. Actually, by creating additional tasks for optimization and for bug fixes, we could achieve next benefits. So we could complete the refactoring within the original time frame. We could not affect the other team's work, and we would have the documented additional issues for the future improvement. And this would have allowed us to properly plan and estimate the follow-up tasks. Next, communication is the key. Actually, a lot of problems could be solved just simply by communication with the team, with the stakeholders, with your manager. So clear communication about the scope, the risk, and potential improvements discovered during the refactoring helps manage expectations and allows us for better project planning. And last one, the refactoring should be small and focused. So in the book that I mentioned before, there is a nice quote. If someone says their code was broken for a couple of days while they are refactoring, you can be pretty sure that they were not refactoring. And I love this quote because actually it answers a lot of questions. So effective refactoring should be small, manageable, iterative tasks, and most important, then they should be safe. So let's take a look on the typical scope of refactoring. Usually, as I mentioned before, they should be small, such as renaming variables, eliminating code smells, replacing magic numbers with named constants, simplifying complex conditional logic, and, for example, dead code removal. All these techniques you can find in the book that I mentioned before, written by Martin Fowler, Refactoring. I will leave you a link in the description, or in the end of my presentation there will be a link as well. And in more compact way, you can find those techniques, I guess almost complete list on the website refactoring.guru on the in the section of refactoring. So regarding refactoring, that's all. Let's move next. Let's move to the rewriting. And rewriting, actually, it's quite obvious. During the rewriting, we are discarding some system or subsystem and writing it from scratch. And it's quite ultimative approach, actually, and I guess in my experience it was not quite often as other techniques. So let's talk about the benefits of rewriting, what we have, what we can achieve from rewriting. Yeah. Usually, if we are doing something, we are rewrite something in a good way, usually we are trying to use modernized technology stack. And again, if we are doing everything right, we should not have a technical debt because it's a new project, new code, so no technical debt. Of course, you can rewrite anything from scratch with a lot of technical debt, but I guess that's not our way. The next one is easy maintenance. No legacy, no technical debt, easy to maintain, and we wrote the complete code, so it's quite obvious. As well as newer code usually have better integrations with the new system and APIs. And of course, it's fun. I guess it's always fun to write something from scratch. Actually, I like it quite a lot. But on the other hand, this ultimative approach has a lot of downsides. For example, high cost. Actually, it's quite obvious that writing something from scratch, especially the systems that already working, can require a lot of resources, money and time. And it's quite a lot risk, quite a big risk that the new system will present the bugs that were not presented in the original system, as well as performance degradation. So original system could have some performance tweaks that you were not aware of, and during the writing the new system you could forget or didn't know about them. So your new system can actually work slowly. And the next one is it's quite often the loss of existing features. So sometimes developers, when they are developing the new system, they can miss the features that were presented in the original system. Next one is over-engineering. So another name for this problem is actually the second system effect. It's a trend that developers usually can create a second system much more complicated and over-engineered than it should be. And with all this new system could be even harder to maintain than original one. And the next one is two systems in parallel. So it's a huge problem and annoying, actually. I met this problem a lot of times. So let's make a small pause on this problem. Usually for some reasons, we can skip or not implement some modules in the new systems that were presented in the original one. And in this case, we need to implement some kind of bicycle, some kind of routing between the systems. For example, as you can see, we got the new system with a set of modules from A to H and the old system with the same set of modules, but there are extra modules I and G that are missing in the new system. So in this case, we need to create some routing between those systems, and as well we need to create some kind of redirects between those modules. So if user from module A wants to get access to module I and G, we need to redirect them. And in this case, the worst part is that we need to support both systems. The new system on the new rails and the old system on the old rails with the legacy stack. And it's quite annoying. And this situation is actually happens pretty often. And for a quite long period of time, you can live with those two systems. And I heard even the stories where people lived with 3 systems in parallel. So it's kind of big problems that you need to keep in mind when you are thinking about the rewriting. You need to be honest with you, with the stakeholders, that you will be able to implement the new system without 2 systems in parallel. So let's take a look on the motivation. What can motivate ourselves to get and rewrite something working in production? First of all, it's quite obvious, it's outdated technology stack. Sometimes it's just impossible to do something. In my example, it's for example from outdated XGS. If you touch this system, touch this framework, for example, we would like to rewrite something from XGS to React or from jQuery to React. There's actually almost no way to do such thing, to rewrite from jQuery to React, to transform from jQuery to React without the rewriting. Next, sometimes our business requirements change so significantly. So again, the only solution for us is just to rewrite the component, subsystem, or system. And the second one, the third one is rewriting sometimes is just cheaper. So sometimes in your code there are such amount of legacy and such amount of technical depth. So when you need to implement a new feature in some component or module, it's can be cheaper to rewrite the complete module than trying to something to with it. And actually, that's all regarding the rewriting. And I suggest to change to the re-engineering because it's quite more interesting topic. And actually, it somehow combines two techniques of refactoring and re-engineering, refactoring and rewriting. So what do we know about re-engineering? Initially, the term re-engineering was popularized by the book A Manifesto of Business Revolutions that were popular in the 90s. And the key idea behind this book is to significantly change the business processes to achieve some improvements of the company work. And behind the re-engineering in software development, actually re-engineering is the same meaning. So it's a redesign of a working software or part of it to improve maintainability, scalability, and its performance. And let's compare re-engineering with the other techniques, with the refactoring and rewriting. So during the refactoring, as I mentioned before, our goal is to improve the code structure without changing external interface. During the rewriting, our goal is to create a new system or a subsystem. And during the re-engineering, our goal is to enhance maintainability, scalability, performance, while preserving core functionality. And by approaches, during the refactoring, we are making small code level changes. During the rewriting, we are writing completely everything from scratch. And during the re-engineering, we are modernizing existing system or its components, and actually it can involve significant architectural changes. So be more clear, let me show you some examples of re-engineering from our day-to-day work from Manychat. There will be two examples. The first example is update React from 17 to 18, and usually updating the core framework, it's not some kind of re-engineering process, but in our case we got a huge project with a lot of code, and the scope of work made us considering that this is a small re-engineering process, so we are handling this update like a small re-engineering because of the amount of work we need to do. So to be more clear, let's take a look on the scope of work. So first of all, we need to update all our dependencies, and there are a lot of them. And we have it actually three ways. First one, it's simple. Just update some dependency. It's the simplest one. Second, replace unupdatable dependencies. So we used a lot of dependencies that are not updatable at all, but they have alternatives. So in this case, we need to update the dependency, and we need to rewrite all our modules that are using this dependency to be capable to work with the new alternative. And the second and the worst one, or the third and the worst one, is to write our own implementation for unmaintained dependencies. So, for example, there are a couple of dependencies that are unupdatable without any alternatives, and we were forced to create our own forks or create our own solutions to replace those dependencies, and again rewrite our modules that are used legacy dependencies to work with the new ones. Next, breaking changes in React testing library. So in Manychat we got almost more than 20,000 of tests, and because we are using React testing library, it contains a lot of breaking changes, so we were forced to rewrite a lot of tests. Next one is obvious. It's just refactoring on the code modes of React breaking changes itself, and update React library. So this is the scope of work of the small re-engineering-like project. Let's take a look on the other example. As I mentioned in before of my speech, we have an instrument for creating visual automation for our users. We call it Flow Builder, and this component was developed around 5 years ago. So this component have pretty a lot of legacy code and technical debt, and it has some problems. It had some problems that we wanted to fix. So, for example, for our developers, because of legacy code, usually it was hard to implement new features because they need a lot of time to dive into the structure of this component to understand how it works. Because of the code quality and sometimes the code quality and the amount of technical debt were too much, and we needed to do something with it. And the last problem was in architectural limitations. So this component initially had some architectural limitations that were preventing us for implementing some of use cases. So our motivation to do something with this was reduce time to market for the new features, to help our developers to implement new features on this component, and get rid of limitations that are blocking some of use cases. So the scope of this project was architectural update, code quality improvements, improvements of developer experience by providing public API, improving documentation, and improving test coverage. Initially, we had 2 ways for this component. So we were thinking about what should we choose, rewrite it from scratch or re-engineer it. But in Manychat, we got 7 teams that are constantly improving something, doing new features, writing new code, including the Flow Builder, which is the heart of our application. So for us, while we were developing the new version of Flow Builder, we would force to support all new features and support, again, 2 systems in parallel, which is absolutely no-go for us. And as well, it would affect the performance of other teams. So we decided to go with the re-engineering because we are not affecting the product development, and we got no 2 systems in parallel. So for us, it's like a win-win. And as a result, we got it took around 1 quarter, and we got the positive feedback from the development teams. Regarding reducing time to market, we reduced adding new entity to the Flow Builder from 3-4 days to 1-2 days, unlocked previously impossible use cases, and it was suddenly for us, but by changing the structure of the component, optimizing some services, optimizing the data flow, we actually get a performance boost. So our INP decreased by 15% average. INP, it's interaction to next paint. It's a time when user clicks on something and how much time you need to re-render the page. And the common thing in these 2 examples is that we tried to stick with this flow. I will share it with you, and I guess it will be helpful in your work. So on the first step, we are gathering motivation and the goal. We need to set up a clear motivation why we should do something and our goal. On the next step, we are performing the reverse engineering. So on this phase, we are researching the current code, looking for the possible problems and documenting everything that we found and that can be helpful for us. On the next step, with the knowledge of the current situation, we can already implement a high-level vision, finalize our goals, and perform a planning and risk assessment. And of course, after the reverse engineering, you can understand that, for example, it will be better to rewrite, for example, yeah. And next steps are actually recursive, because it's the phases of restructuring and the forward engineering. On the restructuring phase, we are preparing our code for new features, for new capabilities, and on forward engineering phase, we are implementing those features or capabilities. And they are recursive because you can do restructuring, forward engineering, and till the end. And the last one, and important, is post-engineering. So on this phase, we are gathering feedback, conducting meetings, retrospectives, and on this step, we can actually evaluate was the re-engineering successful or not, and what can we do better next time. So let's switch to the insights. And the first one, actually, re-engineering is hard because you know, it's much harder than creating something from scratch. Because, for example, you got your current state of application. You are thinking, I want to achieve some capabilities, and you are thinking about, I need a state B of my application. And during the re-engineering, you need to think about the ideal result and the roadmap, how you can transform your application from state A, from state B to state B, what steps you need to perform, you need to plan it. And usually this work requires a lot of experience, a lot of knowledge of your current project, and a lot of time, of course. Next one, recording your motivation. So actually, for us, it's really important in Manychat because the motivation is our North Star. It helps us to keep up on rails and not to spread our focus on the things that are actually not important for us in this project. And moreover, the recorded motivation helps us to describe our stakeholders, our teammates, and other members of the company why we are doing something and why we are doing something in the way we are doing this. Next one is reverse engineering is the key to success. Actually, it's quite obvious because the better you understand the current system, the more predictable will be your result, and the more predictable will be your result, and the more predictable will be your work. And as sub point, usually it's impossible to do a 100% reverse engineering for different reasons. For example, it is really time consuming. You can research your code base almost forever, and sometimes it's even impossible because of the amount of legacy and the quality of the code. And next some point, the artifacts that you are leaving during the reverse engineering, such as diagrams, dependency, code structure, documentation, etc., will be really helpful for you during the restructuring and during the forward engineering phase, as well as during the planning. Next one is knowledge sharing. And it's a really important point because no matter how beautiful your new system will be, no matter how many patterns will you use, will you stick to the solid principles or will you implement a clean architecture, if other developers will not understand your code and why it is written in the way it is written, they will always try to break it. So you need to share your knowledge about the system you are making. And such tools as documentation, masterclasses, pair programming will absolutely help you with this. And of course, you can set up, for example, some automatic tools like linters with the custom rules to prevent other developers from breaking the rules of your system. And the last one is feedback loop. And in feedback loop, we got special attention for the feedback in Manychat because it allows you to make your work better. And for example, as an examples of feedback loop on different stage, on the motivation and goal settings, you can validate your motivation and goal with the stakeholders, with the rest of your team, with your manager. On the reverse engineering phase, you can validate your research materials with the architects or with the technical leads, and as well as with your team. Again, on the high-level vision and goal analyzing, you can validate this with the stakeholders, validate the final goal. During the restructuring and forward engineering phase, you can use automated tools like CI/CD, automated testing, monitoring tools and analytic systems, and as well as you can use, for example, code review process. And on the post-engineering, I guess it's an important thing to gather feedback from your users, from your customers, to understand was it successful or not. So that's all regarding the re-engineering, and let's wrap up. In this speech, we covered the basic things about the refactoring, re-engineering, and rewriting. So there is final table. And one more time, we are doing refactoring to make our code easier to understand and easier to work with, and we are the main stakeholders of our refactoring. During the rewriting, it's an ultimate approach that we are using only when there is no other way. And normally we are using re-engineering to prolong the life of our system and transform it from the legacy state to a modern one. That's all. Thank you. You can find the resources on the GitHub. And questions, if any? Yep.
Yeah, so I haven't read the book, but I'm wondering, is this re-engineering approach something that's mentioned in the book as well, in the Uncle Bob book, or is that something that is kind of like I don't know, like another approach that is not part of the
re-engineering?
Yeah.
Actually, you know, there is not a lot of materials about the re-engineering, so there are some articles in the internet, but I couldn't find any books. So it's just based on their own experience.
Because in a way, it seems like it is re-engineering is almost what, you know, he's trying to kind of dissuade you from doing, right? It is like that kind of a higher complexity refactor that, you know, goes beyond kind of small incremental changes. It is basically a big refactor, right?
No. It's like transforming your current system or subsystem from the state that you're not happy with to the state that will allow you to keep up with some requirements that you need to. So it's not refactoring. That's a problem.
I mean, that's like a semantic question. Every company that I have worked at would call that a refactor. You know, it's usually like in the industry when you do exactly that thing that you described is kind of like, you know, we're doing a refactor.
But you know, actually I cannot say that. For example, you need to, for example, sometimes, for example, in the flow builder example, we needed to significantly change the inner architecture of our component, and actually it's more than refactoring, so it's.
I can give you an example.
All right.
The refactoring, we just rewrite the code to improve performance sometimes, or just to improve like readability. Or there are several scope or propose for refactoring because but it is working, but we want to improve for the refactoring. When in re-engineering, we're looking for, okay, we cannot continue with this dependency, so we have to make a lot of effort to continue to improve those resources, those functionalities, those features. So it's something that we are going to go deeper to improve the system. I have a question related to the forward engineering. What do you mean? I think maybe I get, but if you can explain better.
Actually, so for example, regarding the flow builder, on the restructuring phase, we are doing basically refactoring, and we are preparing our code base for the next steps. And during the forward engineering, we are actually implementing new capabilities of the system and maybe new features. So we are preparing code. It's like recursively preparation, implementation, preparation, implementation.
So would you say that re-engineering is more like incremental changes and refactoring means changing it all at once?
No, actually, refactoring and refactoring and re-engineering, they could be made incremental. That's just the way how we are working. We are trying to make everything incremental with a small bunches of code.
So then what's the main difference between those two?
Between refactoring and re-engineering?
Right.
Yeah, so during the refactoring, we are improving the code without changing the functionality, without changing how it's working, without changing external interface. So it's safe change. And during the re-engineering, we can change the internal structure of the component, how it works, its features, its interfaces. So it's more comprehensive approach. And during the refactoring, it should be small, focused, and safe. So if you break something during refactoring, you are doing not refactoring. So for example, it's like removing code smells, removing the dead codes, optimizing the expressions, etc. So it's really small and safe changes.
Thank you for the presentation. I wanted to ask, what was your approach of the giving an estimation for such things, especially for the refactoring, when you said you had to refactor the big components, the super reused modules? How did you approach that? And it seems like it's a lot of risk involved there. So what was your solution to that?
Could you please repeat your question?
What was your approach to the estimation of such thing, like refactoring particularly?
Okay. Usually we are gathering the PBR sessions, so we are making the reverse reverse engineering, collecting information, and then we're gathering PBR sessions. And we are.
It just seems like a lot of risks, especially when you touch the topic with the super reuse components that are used in the whole system, like you said. So I guess that was the hard part to calculate the risks there. I was curious about that.
Well, regarding the first example, the widely used component, it's example from my career, not from the Manychat.
Yeah, and maybe I just wanted to ask you, what would be the next steps? Like, how do you prevent yourself in the future? How do you protect yourself in the future? How do you prevent such situations?
From
refactoring.
From bloating the refactoring task. Yeah,
Exactly.
So yeah, first of all, it's a clear scope of task. So your tasks should be properly have proper description, and clear. For example, for refactoring, it should be really small and clear task without with little. With very small amount of risk, first of all. Second, it's communication. So if you are finding in your work something that will bloat the scope of your task, you should communicate with your team, and maybe you should slice this piece or slice the whole task to the different pieces.
Thank you.
Okay.
After all refactoring, engineering, and everything, what is the actual status of Manychat? Is still monolithic, or you have another approach for front end? How to stand? By the way, if there is future approach.
Future approach.
I mean, you say the backend is PHP. And then front end is React.
Yep.
And you say that in the beginning, it's a monolithic for backend and monolithic for front end.
Yeah, actually, right now we have no plans by changing the approach. So in the nearest future, but right now we have a growing subsystem of Python tools. So
any tips for the time estimation for the release of the milestone or whatever? Maybe you get the experience of the previous work, so we can properly estimate the new re-engineering step or refactoring or forward engineer. It's just because this is the main issue for our developer, used to say when we will release. You get it?
Oh,
it's very hard for everybody.
Yeah, it's a hard question. I guess let's discuss this a little bit later.
Just a quick one. What has been your presenting that business case, when you're presenting this maybe 3 options, 2 options out of it, what has been your biggest frustration and your experience coming from stakeholders?
My biggest frustration from presenting 2 cases.
There is the engineering.
No. Actually, yeah, it's a nice one. I guess the biggest frustration is the fear that we cannot finish it in time.
But when you are presenting it, did they come up with some kind of question before you ever change any code, any line of code? Just when you're presenting it, did you you do the proposal? What's the answer? What's the most frustrating, or like the most annoying, or the most, I don't know, less likely, or more you feel like non-comprehend as a developer or as an engineer? from the stakeholders?
I guess the question, why should we do this way?
And it's related to stakeholders. So let's say you have to convince some business stakeholder, right? Usually, in my experience, when it comes to like refactoring or modifying the architecture without some like shipping an obvious feature, in the scope of that, they will kind of try to postpone that, right? It will usually only come at a point where there's no way around it, right? So do you think it's worth trying to do it as early as possible, or does it maybe actually make more sense to wait until the point where you absolutely cannot delay it anymore, and at that point you will have more information and will be able to build a solution that will cover more future needs? Does that make sense, the question?
Yeah, I guess so. So, I already said that I'm in the technical core stream. So our work is to make product better from the technical perspective. So we got the resource for this, and we got some requests from the business. For example, from the head of design, we got the request, hey guys, I would like to maybe in future implement this and this feature. Can we make some, for example, I know you are working right now on the flow builder. Can we make it possible in the future? And we say, okay, we will think about it, and we will make it possible to do in the future.
Okay, so that's the situation where you have like sufficient resources and actual capacity to kind of like be proactive, right?
Yep.
Okay, so in your experience, does this kind of like a forward-looking approach where you kind of like try to predict what the roadmap will be and what the needs will be, is there any like pitfalls in that? Does it, can it go wrong in the sense that you've now invested a lot of work into optimizing some part of the code that, in the end is not as impactful as you thought it would be?
Yeah, of course. Of course, it's about risk management. So, of course, you can do something beforehand, and in the future it can be not used by anyone. So, but this is part of our job to be ensure that we are doing the things that will be helpful for our company. So that's why we are.
I'd like to mention that there are a lot of leaders from Manychat, front-end leaders and engineering managers. So if you have any questions regarding how the things works, regarding like negotiation with the business and team planning, you can address them to our guys, and they will be glad and happy to answer and tell you how the things work at Manychat and in Manychat. Yeah, thank you.
Thank you.
Terrible issue with the refactoring that went wrong. Like, I was like having my Vietnamese flashbacks right now. So but I will ask in private already because the question is quite big. So I guess now we are going to networking part of our event, and you will be able to ask all your questions. And as we noticed, I already told Egor before the event, our networking part is actually bigger than our talk part. So don't hesitate to ask questions. And as mentioned, we have a lot of front-enders here, so communicate and ask, and I will ask also questions. So yeah, it was very nice to see you all here, and let's go to eat pizza. Yeah? Okay? Yay.
And guys, thank you for coming. We're doing events not only with GDG group, but separately. Please follow us on social medias, on LinkedIn. You can easily find Manychat and Manychat Engineering, and follow us. We do a lot of backend topics if you're interested in. And next year we will be going to have like various of events, not only for PHP developers, but front end as well, and many other streams. So welcome to our office to listen to our talks. And if you have any questions after the events, please find me or our colleagues to address these questions to them. Yeah, thank you.